We are going to solve few problems on superposition theorem. So the first problem is determine the current flowing through 10 ohms resistor in the given circuit using superposition theorem. And this is a circuit given and we need to find out the current flowing through this 10 ohms resistor. So according to superposition theorem, when we want to find out the current flowing through any element, the current flowing through that particular element is equal to sum of the currents when individual sources are considered. Here we have two sources, one is 25 volts and other one is 20 volts. Therefore, we are going to first find out the currents by considering individual sources. So first I am going to consider the 25 volt source. Therefore, considering 25 volt source, when we consider this 25 volt source, the other source, that is the 20 volts, has to be short circuited. So this is a final circuit what we are going to have. Here I have considered the 25 volts and short circuited the 20 volts source. Now apply nodal analysis. So for applying nodal analysis, we need to identify the nodes where more than two elements are connected. So this is a node at which more than two are connected. This is another node. So one node I am going to take it as a reference node and that voltage I am going to take it as 0 volts. Now applying the nodal analysis, we are going to write the equation as V minus 25 by 5 plus V by 10 plus V by 15 is equal to 0. And on solving these equations, we are going to get the V value as V is equal to 13.66. Once we find out the value of voltage, the current flowing through 10 ohms resistor is equal to V by 10. That is nothing but 13.66 by 10, which is equal to 1.366 amperes. So in step 2, we are going to consider the 20 volt source. Therefore, when we consider the 20 volt source, 25 volt source has to be shorted. And apply the nodal analysis. Here in the first part, there is no voltage source. Therefore, we write it as V by 5 plus V by 10 plus, in the third part we have a voltage source. Therefore, we are going to write it as V minus 20 by 15 is equal to 0. So when we solve this equation, we are going to get the voltage as V is equal to 3.64 volts. Therefore, the current flowing through the 10 ohms resistor in this case is equal to V by 10, that is nothing but 0.364 amperes. So according to superposition theorem, the total current flowing through the 10 ohms resistor is the sum of the currents obtained when individual sources are considered. That is, I is equal to I1 plus I2, that is equal to 1.366 plus 0.364, which gives 1.73 amperes. So this is the total current that is flowing through the circuit through the 10 ohms resistor when both the sources are considered. Thank you. Consider the second example. Determine the current through 10 ohms for the circuit shown below using superposition theorem. So here this is the 10 ohms resistor across which we need to find out the current, and here we have taken two sources, one is the voltage source and other one is the current source. So when we have the current sources in the circuit, the current sources has to be open circuited, whereas when we consider a voltage source, the voltage source has to be shorted. So here when we consider the 10 volt source, we need to open circuit the current source, that is nothing but a 10 ampere source. So first I am going to consider 10 volt source. So when I consider the voltage source, the current source is open circuited. Therefore, I am not going to represent this current source. So when we take this circuit, I am going to solve this circuit by using nodal analysis. Therefore, I am going to take the node at which more than two elements are connected, and out of those two nodes, one node is always taken as your reference node. Reference node is nothing but the voltage at which the voltage at that particular node will be equal to 0. Now apply the nodal analysis. In the first path, we have a voltage source of 10 volts. Therefore, we write the equation as V minus 10 by the resistance value, that is 1 plus V by 2 plus, in the third path I have two resistors connected in series. Therefore, V by sum of the resistances 10 plus 4, that is equal to 0. When we solve this equation, that voltage V is equal to 6.369 volts. Therefore, the current flowing through the 10 ohms resistor, that is I1, is equal to voltage by resistance. So in this path I have two elements to be connected. Therefore, I am going to write the resistance as I1 is equal to V by 10 plus 4, that is equal to 0.4549 amperes. In second step, consider 10 ampere source. When we consider the 10 ampere source, the 10 volts voltage source has to be shorted. So here I have short circuited the voltage source. So when we consider this circuit, I assume the resistances as R1, R2, R3 and R4, in which R1 is in parallel with R2. As R1 is in parallel with R2, I am going to write the total resistance R is equal to R1 R2 by R1 plus R2, that is equal to 0.666 ohms. In the next step, the circuit is reduced in this particular form. In this, I want to find out the current through 10 ohms resistor. Therefore, as these two resistors are connected in series, the current will remain same. Now I am going to apply the current division rule. According to current division rule, the current flowing through the resistor is equal to the total current into opposite resistance divided by sum of the resistances. So here the total current is 10 and the opposite resistance to 10 ohms is 4. Therefore, 10 into 4 by sum of the resistances. So the resistances that are in the circuit are 10 plus 0.66 plus 4, that is equal to 2.727 amperes. So according to superposition theorem, the current flowing through 10 ohms resistor is equal to sum of the currents, that is I1 plus I2. But when we take this particular problem, the current flowing, when we consider this problem, when we consider the first source, we assumed that the direction of current is in this direction, that is from left to right. When we consider the 10 ampere source, we assume that the direction of flowing of current is from right to left. So as these two currents are in opposite direction, we write this equation as I1 minus I2. Therefore, the total current is equal to 0.4549 minus 2.727, which is equal to minus 2.721 amperes, which implies that the direction of flow of current is from right hand side to left hand side. So this is the way how we are going to solve the problems when two voltage sources are present and when we have one voltage source and one current source. Thank you.